In this question, we have to find out the unit of electrical energy in terms of fundamental SI unit. Although there are various forms of energies, mechanical, all types of mechanical energy, thermal energy, sound, electrical, and like all the forms of energies have the same unit, that is joule. And you can express joules in the terms of fundamental SI unit, but in this question, we will find out first of all the joule in terms of fundamental from its specific circuit. Okay, so because they have mentioned here electrical energy. So, what is the electrical energy provided to this circuit? So, this is the current, a conventional current flowing to the circuit. So, what is the total power delivered to the circuit? Is the power is equals to the current multiplied by the EMF of a circuit. Okay, you can use a simple equation W is equals to Fs cos theta to find out a unit of energy in terms of fundamental SI unit, but we will take specific this circuit and its equation to find the final answer, right? So power is equals to the energy delivered to the circuit per unit time. So if you want to find out the energy, you have to multiply the power multiplied by the time. Since the power equation for the electrical circuit is I multiplied by the EMF multiplied by the time, so we will try to find out the unit from this equation, right? Now, in terms of units, the unit of current is ampere multiplied by the EMF, or the potential difference, have a unit joule per coulomb, because if you remember, the potential difference can also be written as the work done per unit charge. So from here, the voltage, the volts is equals to the joule per coulomb multiplied by the unit of the time is second. Now the coulomb, the quantity coulomb is a derived quantity, okay? And the coulomb is equals to the ampere second, because the charge is equals to the current multiplied by the time taken. So that's why you can put the value, I mean the coulomb can be written as ampere second multiplied by the second. So this is cancelled out, and now we have just left joule, which I already told you that the unit of energy is joule, but it's good that we have seen it from another equation. Now the joule is equals to the Newton times meter, okay? And the Newton is a unit of force, and the force is equals to the ma according to Newton's second law, right? So that's why the Newton should be equals to kilogram meter per second square times meter. So hence this is the fundamental SI unit of energy, which in which all the units are the fundamental SI units. Hi, this interesting question is about the graphs of the motion. The graph that you see in this diagram is the speed time graph of an object, which shows us that the speed with respect to time is increasing and increasing, and then it gets its maximum value and then it is decreasing, which means that that object is accelerating. Now, in this question, we have to identify that which one of the following distance time graph gives us this speed time graph. Okay, so we will go back from the velocity time to distance time graph. So let us investigate it. But first of all, I will explain you that what is the speed and how do we measure it, how do we calculate it graphically. Okay. So speed is nothing, it is just the rate of change of distance. Okay, we cannot say it is the rate of change of displacement, that is the velocity, and velocity is a vector quantity. It is the rate of change of distance. It tells us that how fast or slow the object moves, its distance changes with respect to time. So that's why whenever we calculate the speed from the graph, it is basically the delta s over delta t, which is gradient of distance time graph. So it means that we will see that which one of these following graphs gradient gives us that shape of graph. Okay, so Let us see one by one. Okay, in a first option, which is a option A, well, many of you can easily guess that it is a wrong answer. Why? Because if you notice that there is a equal change in the distance with respect to time in every next interval, the object covers the equal distance, right? It means that, dear students, this quantity is changing equally with respect to this quantity. So this is obviously the graph of a uniform speed. It means the object is moving with a constant speed. So if I draw its graph, then it would be a horizontal line. So this should be the graph of velocity. So it is obviously not giving us that curved graph. Okay, now we will go directly after A, we will go directly to C. Okay, remember one thing. If you are having a here a variable speed, like this is the shape of the graph, right? It's a parabolic shape. We can never have the distance time graph in a same shape. The reason is because if you see, even at that point, the if I draw a tangent line, this tangent line has a maximum steepness, right? And then that tangent line steepness is decreasing, and at that point the tangent line is horizontal. And a horizontal line means if I measure the speed at that point, the velocity or the speed will be zero. Okay, because the slope or the gradient of a horizontal line is zero. So which means that in the starting at the time t is equal to zero, we have a maximum speed. All right. So we can draw from this point and it is getting zero at some time. You see exactly at that time where the speed was zero, I'm showing you the graph touching the time axis, and then we will keep moving it in this. Then the velocity is getting, well, the speed is positive, right? So because this is a speed time graph, so you can draw the same like this graph, which is obviously once again not giving us this graph, right? So option C is also wrong. Let's move to the option D. So for option D, you see the distance time graph is flattened almost in the middle. All right. So I'm talking about at that point where it is flattened. It means that at that point speed should be zero. So I just want to show you at the different points the tangent line so you can have an idea. And I'm going to draw the tangent line at these points. And with the help of the steepness of those tangent lines, you can get idea that how the speed is generally changing. So you see that the speed is decreasing and then it is once again increasing, right? And all this speed is already always a positive because it's a scalar quantity, right? So anyways, at that point, the velocity or the speed is zero. So if I draw its graph, so dear students, you can see it is obviously a very high value in the start, and then it is getting zero, and then it is increasing to the same value once again. This is not a correct option. What about this? So let us see. Let's explore. Obviously, this should be the right answer, option B. But let's see how is it right answer. So do you see in the start at the time t is equal to zero, the speed is zero, right? And then the speed is increasing, and exactly at this point where I'm drawing tangent line is the speed maximum. And after that, speed is positively decreasing, or the velocity is positively decreasing. Speed is always positive. So ultimately, at that point your speed is once again zero. So exactly at this time the speed is maximum and it is starting from zero, so it should be like this. All right. And and then again it will go like this, right? So exactly at that time the speed is again zero, so which is obviously 100% relating with this graph. So the right answer should be option B. Hi, in this video, we will analyze the motion of this car and expressed by the acceleration time graph. And basically, we will try to find out that what is the total change in velocity throughout the motion. As you see from the graph that the motion is ending at that point at the 6th second. So at the 0th second, what we observe that acceleration is maximum. Okay, which means that we can uh, visualize that basically the maximum force was applied on it. It possessed the maximum acceleration. It has a maximum change in velocity in a first interval. So that's why you also see that the distance covered in this interval is maximum, and the distance covered in every next interval is decreasing. Why? Because look at the graph, acceleration is decreasing. So that's why is the velocity is increasing, but the distance covered in every next interval is decreasing. So this is the time at the t is equal to 0 second. So let's say this is the time t is equal to 2 seconds. Then it's the second position, and then this is the sixth second. And afterwards, what we observe that at the sixth second, when the acceleration is zero, it means that the velocity will be constant. So that's why I have shown you properly that the distance covered after 4 seconds in every next interval is same, which means that the car is moving with constant velocity. Anyways, this was all the explanation. Now let's come back to the question. We have to find out the change in velocity in the first 6 seconds. Right now, from the acceleration time graph, how do we calculate the change in velocity? That is the characteristics of the graph. We can simply calculate the area under this line. Okay, this will give us the total change in velocity. If they are mentioning for the 6 seconds, so then we will calculate the area under this whole graph, right? So it is a triangle, so that is 1 over 2 into the base of this triangle is 6 seconds, and the height of the triangle is 12 meter per second square. So that is obviously how much is 36 meter per second. It means that at that time, when the maximum force was applied at that time the speed was zero. But at the sixth second, dear students, the speed is maximum, which is equal to 36 meter per second. So the right answer is option C. And by the way, if you are curious that how the speed is changing throughout this time with respect to time, so we see that acceleration all the time is positively decreasing. So which means that the graph of the velocity time can never be a straight line. It should be a curved, it should be like this curve, right? At that point acceleration is zero because the tangent line is horizontal. So I hope you understand this solution. This question discusses the application of Newton's second law, which you know is always applied to the accelerating system. You can see here a elevator or the lift that carries a load and their combined mass is 750 kg. And what we need to calculate in this question is the force of tension in a cable. So the tension in a cable is in this direction. And provided information is that the acceleration is downward, and that acceleration is, I would say, negative 2 meter per second square because of its direction. Otherwise, the magnitude is 2 meter per second square. Now, this downward acceleration means that the system's weight is more than the force of tension. But we need to calculate the tension in a cable, at the end of the video I will compare this scenario with this scenario if you are in a lift and how your apparent weight changes. So you should solve any forces question by first of all drawing the free body diagram, and I'm supposing that this is a system contains a load and the elevator, and the force of tension is obviously upward. So this is the tension in a cable, so this is a force of tension D, and the weight should be downward and it should be more than, so I will draw the lengthy arrow. So let's say it is mg. Now the second step is always to write its equation by using Newton laws of motion, and since it is accelerating downward, so we should use Newton's second law. So according to Newton's second law, you know F is equals to ma, but this F is the resultant force, so that's why I'm writing it F net, the resultant force. And in our case, since the mg is more than the force of tension, right? So you can write this equation like this: ft minus mg is equals to m into negative a. Otherwise, you can also write mg minus ft is equals to ma. So we can find out the value of force of tension. The force of tension in a cable will be equals to mg minus ma. So the weight of the elevator is 750 times 10 minus 750 times 2. So this is a force of tension in a cable. And its answer is 6000 Newton, which you can also write 6.0 kilo Newton. So that's why its answer should be option B. Now let's quickly compare this situation. So for example, if her mass is 50 kg, so her mg value should be equals to 500 Newton. So that is called the real weight. Now, so if she accelerates, she is in an elevator and the elevator is accelerating down with negative 2 meter per second square. So then the bottom scale, this weight measuring machine, will not read 500 Newton. Apparently, her weight will be decreased. And how much is that? So in this scenario, the force is the normal force applied by the machine, and this is her weight. So so the normal force minus mg is equals to negative ma, and the normal force is equals to, because this normal force right now is its real, sorry, apparent weight. So you can put the value and find its answer. That will be obviously less than 500 Newton, because when this elevator is accelerating down, so she is not able to press the machine with such a amount of force, with such a strength, because the machine, elevator, and everything inside is accelerating down. So she is unable to press down the surface of the bottom scale. So that's why the bottom scale will not read its that value of the normal force. So that will read the force less than 500 Newton. So this is happens in the accelerating system when your real weight is not equal to your apparent weight. Hi, this question is about the conservation of energy from the topic 8.3 work energy and power from your IB curriculum, and we are going to consider the energy transformation from the elastic potential energy to the kinetic energy. And so let's suppose that this is a original length of the spring L0. It's the equilibrium length of the spring. And what we did, we attached a mass with it and we compressed the spring. So we have given it energy, and this is a new length. So what is the extension value, or what is a compression value? That is, so we compress the spring by this distance y, which you can also consider the amplitude, because this is the maximum distance by which we have compressed the spring. So when you were compressing the spring, how the energy was incrementing in the spring, and then how the energy is delivered to the object with which it moved, and it acquired the kinetic energy. That's what I will explain you in this video. So what happened in the question, it is clearly mentioned that the distance y, the force will increase. So if I take on a y-axis the spring force, and on x-axis I'm going to take a distance. So how the spring force is increasing as you are compressing the spring more and more. So this should be a straight line. Remember that I'm just taking a magnitude of the force as well as the distance. Otherwise, according to the Hooke's law, you know very well that F is equals to the negative x. So that should be the straight line, but like this straight line. And this distance here represents the compression distance of the spring, that how much you have compressed the spring. So if I want to know what is the total work done on a spring, because that work done is equals to the gain in elastic potential energy, because then that elastic potential energy is converting into the kinetic energy of this object of mass m. So let's find it. So work done is equals to the gain in elastic potential energy. So according to the question and diagram, what we see that we have compressed it to the distance y. Okay. And when we compress to the distance y, that is our amplitude as well, at that moment the force in a spring is maximum, and that force is obviously ky. So if you find out the area under the graph, which is obviously this area, so that area represents the amount of energy stored, which actually is coming from all the work done, right? So if you find out this area under the graph, that would give you the total amount of elastic potential energy stored in a spring. So right at this position, the spring have the maximum energy stored, which is obviously coming from the work done. So that work done is equals to 1 over 2 half of the base and the height of the triangle. So what you get is 1 over 2 ky square. So this is the total elastic potential energy stored. And when you will release it, so it has a speed v. That's why right at this position it have the kinetic energy ek is equals to 1 over 2 mv square. So simply this elastic potential energy converted into this kinetic energy if there's a no friction at all. So finally, we are so close to find out the speed when the block will be released from the spring. So that is half mv square is equals to 1 over 2 ky square. You can just simply solve it, and mv square is equals to ky square. Okay, one half is cancelled from both sides, and we want to find the speed. So we can divide mass on both sides. So ky square over m, and then you can take the square root of on the both sides, so it will be equals to the square root of k over m into y. So finally the option a is the right answer for this question. In this question, we have to find out the power that is required to maintain the constant velocity of the car despite of the resistive forces. Either it's a air drag or it's a frictional force by the ground. So the car engine is giving the constant thrust of 1500 newtons. So this is a force that the engine is applying to maintain its constant velocity, because there are the other forces. So that might be the force of the friction, the dynamic friction, or that might be the air drag, so ft. So in order to overcome these resistive forces, a 1500 newton of drag is required to move it with a constant velocity. And what is a constant velocity? Because it is moving with a constant speed, so you can find out simple: 100-meter is covered in 5 seconds, so that is 20 meter per second. Now what is the power? Before we directly apply the equation, let me show you what is the relationship between the power and force and velocity. So you know the power generally is the rate at which work is done. Now this work done is equals to right now the F force into the displacement, and in fact it is the, because the constant force is applied by the engine, so the displacement is increasing with respect to time. So when the power is constant, sorry, when the speed is constant, so you can say that this delta s over delta t, which is the rate of change of displacement, which is average velocity, is equals to instantaneous velocity. When the velocity is constant, then the instantaneous velocity at any instant of time can be written as average velocity, which is equals to delta s over delta t, is a gradient of displacement time graph. So the power, that's why it's a product of the force and the velocity, and we have to simply multiply it. 1500 multiplied by the 20, that will give us the 30,000 watts. So we can write this 30 kilowatts. So that's why the right answer is option D. 30 kilowatt is required to maintain constant velocity of the car. Hi, this cyclist is accelerating forward due to its mechanical force applied. in a forward direction, but no, that is not just a single force applied on him. There's another force that is a air drag. So that is, these are the air streamlines, okay, because the air is a fluid. So just imagine that due to this air streamline flow, there is also a drag produced on him, on his system, right? So this is a drag force. It is 10 newtons, or you can say 10 kilogram meter per second square in a fundamental SI units. So the force that is applied, the mechanical force applied by his body, is equals to 40 newtons. Yes, so this force is equals to 40 newtons. That is 40 kilogram meter per second square. So what is a rate of change of momentum? Now they are not asking the change of momentum. That is impulse. They are asking the rate of change of momentum, which that is equals to ma, and this is the net force applied, or the total force applied. So that should be equals to, dear students, the net force, the resultant force applied is 40 minus 10. That is equals to 30 kilogram meter per second square. This is the total resultant force, and the 10 Newton is a drag force. So the right answer should be option B. Hello. This question is about the thermal energy transfer from a liquid. And obviously, you see that this is a liquid. Why? Because you see, inside the liquid, I have shown you intentionally that the molecules have a more space between them. So we are going to take heat out of the system so that this liquid will undergo the phase change until it will convert into this solid form. So basically, what is a phase change? First of all, try to understand this thing. So it is a process during which the one state of matter converts into another state of matter at a constant temperature, into another state of matter at constant temperature. So now one valid question that someone can ask, that if the temperature does not change, then why is that? Because the heat is continuously going out of the system. So heat is coming out of the system by any mechanism. So then why the temperature is not changing? So the reason is that, and this reason is applicable for all the phase change, either liquid is freezing to the solid, or the liquid is converting into is vaporizing. Okay, so the reason is the heat that is transferred out of the system during this, so chemical bonds are forming between them. And secondly, you see that the distance between the mean position between the molecules are greater than in the solid form. The molecules are close in a solid form. So I can say the molecules in a liquid form have a more intermolecular forces of attraction, because the molecules are at a larger distance, at a larger position. So what is happening, the heat that is taken out of the system is not changing the temperature, rather it is decreasing this intermolecular forces of attraction. So it means that the heat is independent of the change of temperature. So that's why there should be no change in temperature taken place. So it means that the only right answer is this option A, in which the temperature does not change during the phase change. Hi, this question is about the pressure exerted by this cylinder, which is hollow from inside, and I have shown you here its 3D view. So you can easily see that this is a hollow, and I can consider this is its axis of rotation. Okay, so important thing is, you see that this is its thickness, right? So which is basically the value x according to the question, and you can easily say this thickness over here, so this value is x. And one another important thing to note, in the question they have mentioned properly that the radius of the cylinder, which is its distance from the center to this that end, this radius r is noticeably larger than the x, right? Which means that the r is much, much greater than x. Okay, so it means that if, let's say, if I take the square of x, right? So I can assume it is 0 because it is comparably very small. So it is placed on this flat surface, and we have to find out that what pressure does it exert on this flat surface if its weight is W, right? So W is its weight, which is passing from its center of mass, and it is exerting force on this flat surface. That is a normal force, and this force is the pull of Earth on the cylinder that we are calling the weight W. Another thing, so what surface is making contact with the flat surface? What part of the cylinder? It is very important to note what part of the cylinder is making the contact with the flat surface. So you would see that it is obviously this part. If I shade it for you so you can see that this is basically the thing that is making contact. Okay, so it is exerting force on a flat surface. So it is very important to note to find out the area of this surface, which is not pi r square because this is hollow from inside. So how can we okay, so let's see. We want to find out the pressure, and the pressure is always equals to the force, normal force per unit area. So the force here is the weight, okay? So the W over area A. So area is basically the area of that part of the cylinder which is making contact. So why not if you find the whole area, like I mean to say the area, the complete area of this thing, okay? So don't you think it should be pi r square, right? Pi r square. And if we find this area, the area of this hollow part, okay, but before we find the area of this hollow part, we must know that actually uh what is the radius of this hollow part. Okay, so I explain you this, that from the center of the hollow cylinder to this point, the distance should be equals to basically r minus x. The reason is that this distance is the thickness of this side, and the total distance is r. So this will give you the radius of this circular part. Okay, so this is a horizontal circle. Anyway, so if you want to find out its area, so dear students, this area should be equals to pi into r minus x whole square. So I was saying that if you want to find out the area of effective part, which is exerting pressure, so that should be equals to the total area pi r square minus this area r minus x whole square. So it is pi r square minus pi into r square plus x square minus 2r x. Right. So if you open the brackets, so pi r square minus pi r square minus pi x square and plus 2 pi r x. Right. Now we can cancel out this pi r square with this pi r square. And secondly, you remember that I told you the x is comparably very small, so its square is almost negligible. So we can make it almost zero, right? So I think it's not complicated thing. So what is it left behind? So effective area is just 2 pi r x. So hence, when you will find out the pressure, I told you the pressure is equals to the weight over the area that is effective. So it is 2 pi r. So the right answer is option A. If you look at this question, the option A is exactly this. Hi, this question is about an ideal gas, and you see a container which contains an ideal gas. So these are the molecules according to kinetic molecular theory. The ideal gas have a large number of molecules which move in a random directions with different velocities. They hit with each other and they hit with the container walls as well. So they exert force on it. Okay, now, what is asked in this question? They say if we increase the average kinetic energy of the gas. right, of all the particles, of all the molecules. If it is doubled, then what will be the new volume? But remember the condition which is mentioned, that the pressure is constant. So first of all, we will find out the result by having an equation, an accurate result, but I will also tell you the conceptual side, that actually how the pressure was constant and the volume should increase or decrease. So stick with the video. So finding answer from equation is so easy, right? First I tell you what is the average kinetic energy. It is the sum of, it is an average of kinetic energy of all the molecules, right? And the kinetic energy of one molecule cannot be determined, but the average kinetic energy can be determined from the macroscopic property, which is temperature. So you know the average kinetic energy can be written as 3 by 2 Boltzmann constant times the absolute temperature, which is measured in Kelvin. Now, if they say the temperature is doubled, if it is doubled, it means that the temperature was also doubled. Okay, it simply means that it is also doubled, because it is directly proportional to temperature. And by the way, why it was doubled? Because it means that we have given the heat to the gas. So this heat entered into the gas, it increased the kinetic energy of every particle, and hence the speed has increased. Okay, so when the speed has increased, these particles have exerted more force on the piston, on the piston of this container, and it is perceived, it is most probably that the gas should expand. Obviously the gas will not compress, okay, because now the gas possess higher internal energy. Okay, so well, I will come towards the conceptual approach later also. But if you apply equation, which is obviously, which equation should be applied, that is PV is equals to nRT, because that is for an ideal gas. So what factors are constant? So this is a gas of a fixed mass. So the volume can be written as nr over p, if I write it in a one bracket, because all the things inside the bracket is constant times the temperature, right? So dear students, this is equation number one. You can say that this is the original volume. So after doubling the kinetic energy, I told you that the temperature will be doubled. So then the pressure is still same. So this is a new volume is equals to n is a constant, r is a gas constant, and this is the T prime. So V prime is equals to n r over p into t prime, and you can put the value of t prime here, so which is 2t, okay, because we have double the temperature. So if we substitute the value here, so it will be equals to nr over p into 2t, right? So obviously what it is getting to, so it is, you can write it like this. So it is 2 times nRT over P, which is the original volume before doubling the kinetic energy. So V prime is equals to 2V. So that is the right answer of this question. Now let's talk about, on a conceptual side, it is good if you understand it as well. So the right answer should be C, which says it is 2V and not the other answers. Now, just quickly go through this idea that why the pressure was constant. So we know that the pressure is equals to the force over area, and here they are basically talking about the pressure of a gas, right? So why it remained constant? The reason is we know from the Newton's second law that the force is a rate of change of momentum. So delta P over delta T over area. Now here the area is, dear students, is the area of the piston, right? Which is not going to change. This area is obviously remain same before and after doubling the temperature, right? So it means that the only change that happened in a system is about the force, right? Something happened, the force remained constant. And why the force remained constant? Because force is a rate of change of momentum. So what we did, when we have delivered heat to the system, the molecules are now moving with the more velocities, right? So when they are moving with the more velocities, so this change of momentum will increase, because this is equals to negative 2 mu if a particle have a mass m, right, and the speed is u. So it is negative 2 mu over delta t. So what happened when you have increased the temperature, the speed of the molecule increased. But at the same time, to keep the pressure constant, the gas expands, right? Why gas expands? Because this time factor should also have to increase. Only in that case, the force can be constant. So I hope you understand the logic, that why the pressure is constant because force is constant, and why the force is constant because the momentum changed and the time that took two particles to approach each other, they changed by the same amount so that their ratio remained constant. Okay, so this is why the pressure is constant. So it means that the volume will increase. So that's why, and mathematically we have proved that this should be 2v. Hello. This question is about the simple harmonic motion, and on the screen you can see the velocity time graph of the particle which is executing the simple harmonic motion. Now, since they have said it's a simple harmonic motion, there are various examples of simple harmonic motion, and one of that I will show you on the left hand side of my screen. So the simple harmonic motion is a special case of oscillatory motion in which acceleration is directly proportional to displacement, but always directed towards equilibrium position. So this velocity time graph shows us that at the time t is equal to 0 seconds, the velocity of the particle is maximum right at that point, which means it is maximum negative. And one of the famous example of SHM that I'm going to show you is the mass spring system, horizontal mass spring system, which you can see on the left hand side. So I've shown you the different the mass spring system setup, which is actually showing you the different positions. I will talk about them later. So right now, this is our equilibrium position, and this must be the positive extreme position, and this must be when the particle, when the mass will have a negative on a negative extreme position. So right now you can see that going to show you the position of the mass at equilibrium position. Velocity can be only maximum, either it's positive or maximum negative, can be at equilibrium position. And it shows us that the the motion is towards left. So by the way, what we have to do in this question, we have to draw acceleration time graph, which will be one of them. So let us see. So so in order to check the acceleration time graph, that how the acceleration will change, first of all we should give the values of time, right? Because this is a half cycle, so I would say it is t by 2, right? So the same is here, it's t by 2. So and here is the one complete cycle, one complete oscillation is completed. So this is t. Don't you think that whenever the object is at equilibrium position where the displacement is zero, it means that acceleration is also zero, because acceleration is directly proportional to displacement. It means that our graph will start from the origin, either it will be a positive sign or it will be a negative sign graph. We will decide it later. Secondly, if you notice, at that point, if I draw a tangent at that point, so the tangent is a horizontal line. So if I find here the slope or the gradient of the velocity time graph, that gives me a zero value, which again shows us the same concept that acceleration must be zero at the time t is equal to zero. Now let's talk about this point. At this point, dear students, which I can say the instantaneous time is t by 4, right? T by 4, and since the object is moving leftward, so in that quarter time this object should be exactly at the extreme position, means that at this position. And don't you think this is a position which we say is a negative extreme position, so where the displacement is maximum negative? But since the acceleration is directly proportional to displacement, but it's in opposite direction always, so it means that at that point the acceleration must be positive maximum value, which is exactly endorsed from the graph when you try to find out the gradient. So I will show you this, that this is the tangent line, and this tangent line has a maximum slope or gradient, which means that the acceleration has been started from, I mean, increasing from 0 to the maximum positive value. So that I will exactly show you here. This is acceleration line graph, and right at that point you can see acceleration is going like this. So which means that all of the options, like B is wrong, C is wrong, and even D is wrong. So option A is the only right answer. But please, before you leave the video, just quickly see the other positions. So next position is this one, and notice that tangent line is horizontal, which clearly means that acceleration must be zero. It means that this graph is now confirmed. It's a positive sine graph, and that will go on like this. So it's two cycles. And how the particle will change its position. So these are the different positions, and I'm going to show you exactly the instantaneous times as well. And after 1/4 time, it will return back to its equilibrium position, and that will be a completion of one oscillatory motion of this SHM. And these are the graphs, and I hope you understand the whole answer. Hi, this question is about the traveling wave in a string, which is transverse in nature, because if you see from the diagram that the string is vibrated by moving it up and down, so that a wave will travel with a speed of 40 meter per second in this direction. So each and every particle of the medium will actually execute this motion up and down, whereas the wave is going to travel in a forward direction, just like you see in a diagram. So that's the time period is 5 second, 5 millisecond. And in this question, you have to find out the phase difference between the two particles, which are how much distant apart. They are 0.050 meter distance apart on the same string. There are the numerous amount of particles which all are executing SHM, simple harmonic motion, by moving it up, down, and the wave is traveling to the right. So I will show you the two techniques, the one, the very easy and the very direct method, and the second is from the diagram, which is going to be very useful. And especially at the end of the video, I will show you what it means for those two particles which are executing SHM. So I will show you their motion. So first of all, let's start from the direct method. So if you want to find out the path, the phase difference, so this is a equation 2 pi over lambda multiplied by the x. Now the x is a distance between the two particles, and this equation is always useful, always applies for this type of coherent wave whose time period is constant throughout. So the let's say the 2 points, the first point is at here, right? And the second point, wherever it is, the distance between them is 0.050 meter. Now we need right now the wavelength, and the wavelength is equals to the speed of the wave, of the traveling wave, divided by the frequency, right? Which you can obviously write like this: v over 1 over time period. So you can say lambda is equals to v multiplied by the time period, and the speed is 40 meter per second multiplied by 5 milliseconds. So 5 multiplied by 10 to the power negative 3. So dear students, that is going to be 0.200 meter. This is the wavelength of a wave. So now let's plug the values in the equation, multiply by the distance between them, which is 0.050, and obviously that is going to become 2 pi, because this is, if you divide it, it is 4, right? So the answer is 2 pi over 4, which is equals to pi over 2, which means that those two particles are at the phase difference of 90 degrees. So that should be pi over 2 radians. So the right answer is option B for this question. Now let's talk about the second method, which is from the wave diagram, right? It is going to be more useful for, because many students do not know this method. Now, so if this is a one complete wave, which I have just shown you, and we know that now their wavelength is 0.200 meter. So if this is lambda, then this is a half wavelength, which means 0.100 meter, and then this point is exactly lambda by 4, right? So it means that if I am considering the one point, the one particle is at this point, then the other particle right at that time, it was at its extreme position. Okay, so if this is the equilibrium position during the SHM, right, I mean to say this is the equilibrium position. So which means that right at that time, the other particle is at its extreme position. And this is exactly what I was going to show you at this place, right? So when the one particle is at extreme position, the other particle will be at equilibrium position. So this is how they will execute their simple harmonic motion. So the distance between them is, this is 0.050 meter, which is one quarter of a one complete wave. So if this is the wavelength axis, and now here I'm going to show you the angle. So in a one complete simple harmonic motion, the total angle that is covered is 2 pi. If you relate the circular motion with a simple harmonic motion, then this must be the 2 pi, and this half cycle, the half vibration, represents the pi, and this represent exactly pi over 2. So that's why I was saying that the right answer is pi over 2, the option B. Last but not least, just quickly see here, when the one particle is at equilibrium position, the other particle will be at extreme position. X is equals to positive x0. When the this particle will move up because it is executing SHM, this particle will move down and its new position will be this one at equilibrium position. So that means the phase difference is 90 degrees or pi by 2. This question is also about the polarization of a light, which is a property of the waves, and it's not included in the new IB syllabus. The important property, which is polarization of a light, was part of our old IB syllabus, so it's not included. Hi, this question is related to the standing waves produced in a water tank. And you know that is always produced due to the superposition of the two longitudinal waves, means sound waves, in the water tank when the sound travels through air. Anyways, in the diagram you see that initially, actually imagine that you are doing an experiment in which you have filled a whole tank of water up to this level, right? And you produced an orifice close to the surface of the tank. Imagine at this point from where the water started rushing out. Okay. So, what we observe the first loudness of the standing wave when the water reached at this level. And then we heard the next harmonic, means the next loudest sound of the standing wave when the water level reached at that point. And in this question, we have to relate the wavelength with the value of x. And the value of x is actually this distance between these two positions. So if this is x, then how is the wavelength of standing wave is related to the x? But first, I will insist you to kindly understand that how actually standing wave is produced. So this is a tuning fork which is vibrating right now. So it is propagating its energy through the air, which is acting as a medium. So this is a certain air particle. It is executing a longitudinal wave, a longitudinal vibration. So it is vibrating like this, due to which a sound will travel. If I draw the sound like a transverse wave, but sound is a longitudinal wave. So this is a one sound wave. When it reflects back from that end, that's why we always have a node at the level of water. Okay, So these two sound waves superpose with each other, they overlap with each other, and they produce the standing wave. That's how a standing wave is produced. So all the air particles, they execute SHM. Now, so here starts the important part of our video. So look at the first loudness position. As I told you that the first harmonic standing wave is produced. So why not we should produce, I mean, there should be antinode always at the opening end, because the particles can vibrate with their maximum amplitude is it is open end. So that's why we will have always an antinode. And the at the surface of the water we will always have a node, because the motion of the particles is restricted. So that's why the first harmonic should be like this, and this part will be the dotted one. Okay, so this is the first harmonic. Now at the position of the second loudness, we have to draw the next harmonic, which is the third harmonic. Okay, so this is obviously the antinode, and then this is a node, right? But there will be another antinode because it is a next harmonic. So the wave should be, we should draw like this. I hope you understand. So we can say that because this is a distance from antinode to the node, so that must be lambda over 4, obviously. Okay, whereas in the next, you see that this is an another antinode. So from the antinode to antinode, it's lambda by, so this is lambda by 2, and this must be lambda by 4 because it's from antinode to node. So the total distance, it should be, just simply add them. So lambda over 2 plus lambda over 4, that must be equals to 3 lambda over 4. So why not if we subtract this distance and this distance, that must be equals to x, right? Do you like this idea? So x must be equals to 3 lambda over 4 minus lambda over 4. That's why it should be equals to 2 lambda over 4, and that's why it should be lambda over 2. So what we finally conclude that x lambda is equals to 2x, and on the basis of that, the right answer should be option D. Hi, this question is about a motion of a charged particle in a uniform electric field. But first of all, how a uniform electric field is produced and how does it looks like? So you can see in a fundamental concept that if you maintain the constant potential difference between them, so just like in our question, it is mentioned that 2.5 megavolts, 2.5 million volts is maintained constant potential difference between the plates, then you can produce this uniform electric field. What does that mean? It means that if you take any point in this vicinity, in this space, at that point electric field will remain constant, and that will be uniform throughout. At that point also, the electric field will be same. And if you want to find out its electric potential, electric field strength, so you can simply divide the potential difference and the distance between the plates. Now coming back to the question, let's say if this is an electron that is just released from that point, obviously it will be accelerated because of the opposite charge plate. So it will accelerate towards the higher potential. So when it will accelerate, what kinetic energy will it gain in order to cover this distance from the negative plate to the positive plate? Or even if it's not mentioned from negative to positive, we are just given the potential difference. Okay, that is delta V, right? It doesn't mean that it's going from negative to positive. It can go anywhere from this point to this point, but between those 2 points the potential difference is given to us. So dear students, now in order to calculate the change in kinetic energy or the gain in kinetic energy, we need to calculate the work done, and that work done according to the work energy principle, it is equals to uh, change in kinetic energy, right? So either this charged particle will gain kinetic energy or lost kinetic energy, equal amount of work will be done. Now, what is that amount of work done? I just want to quickly show you what is a relation between the work done and the other quantities. Now, we will start quickly from the general the formula of the work done, that says that the electric force times the displacement covered, and I assume that the angle is, now the angle is even 180, but in this case, the electric force and the displacement are in the same direction, so angle is zero. So electric force is EQ, and I'm writing E because E is constant. Q is a charge on electron, and S is the distance between the plates. Because in my specific this example, I'm assuming that it's going from a negative to positive. As I mentioned you, it is not necessary. So it is EQD. Now, this E and D is equals to the potential difference. So it means that the work done in that region is always equals to the potential difference into the charge. So we are going to use exactly this thing here. So it is 2.5 multiplied by 10 to the power 6 times 1.6 times 10 to the power negative 19 is equals to the change in kinetic energy, and that will be, so it is 4 multiplied by 10 to the power negative 13 joules. Okay, and that can be written as, in a scientific notation, okay, it's already in that. So if you take the point, bring the point before 4, you can write it like this: negative 12 joules, and 10 to the power negative 12 is called pico, right? So we can say zero point 0.4 picojoule. So you have seen, and this is, by the way, the option C. So option C is the right answer. And you, now this zero point 0.4 picojoules means that whenever the electron will traverse the distance in which the potential difference is 2.5 million volts, this much energy will be the change in kinetic energy. Now this doesn't mean that it will gain kinetic energy or it will lose kinetic energy. It totally depends on the direction of that electron. If it is accelerating towards the higher potential, then it will be the gain of kinetic energy. Then otherwise it will be the loss of kinetic energy. Hi, this is a metallic wire in which the current I is flowing. So let's say this is a direction of current. So this I current is, the current is basically the rate of flow of charge. It doesn't say that it is the flow of charge. It tells you that how many charges have moved through certain cross sectional area in per unit time, in per second or per minute or per hour. That what current is, and it is measured by the ammeter. So right now in a question also, we are taking this plane which is perpendicular to this metallic wire, and this plane is P. So you can see that these are all particles. Like, by the way, all of these are electrons, and every electron have a charge E. According to the question, they are moving in a certain direction, and they are basically going to cross this cross-sectional area, this plane. And in our question, we have to find out the number of electrons per second, means basically N over T. So it's a very easy question. We will and we will start from a simple definition of current, which you know is I is equals to the total charge that flows through this cross section area through this plane per unit time. Okay, which you can also write Q over T, by the way, simple, in simple words, right? So I told you that this Q charge is not a single electron. It is made up by a lot of a numerous amount of electrons. So I would say, generally speaking, it is made up by the n number of particles, and every particle have a charge E divided by T. So if you want to find n over T, right, so that would be equals to I over E, that is equals to n over T. So it means that our right answer should be option D, that is I over E. Hello, this question is about the motion of a charge in a magnetic field. So let's start with the electron that is moving with a speed v perpendicular. It's very important to note that it is moving at a 90 degrees normal to the magnetic field, having a magnetic field strength B. So you see that this magnetic field strength is applied into the plane, which I have specifically shown you in this section of fundamental concepts, that this field is going from north to the south, and this is external magnetic field going into the plane, or you can consider going into the negative z direction. If you take this is the x-axis, this is a y, and this is a z-axis. So this is the direction of the magnetic field strength, and that is in a negative z direction that we always show with the help of this cross. So when electron will enter into this field, and right now you see this is an electronic gun that is emitting electron in a unidirectional way. So the electron is entering in a straight direction here. So the moment when electron will enter at that point, this is an electron, it will bend and it will move in a circular path, and it will experience a force F given into the question. So our question is, what if you throw an alpha particle with the twice the speed of electron in the magnetic field which have a twice the strength, but you throw the alpha particle parallel, then what will be the force? So dear students, I explain you the alpha particle later. First I will show you what will happen to the electron. So this is the direction of the electron's velocity. Let's say it is moving with the velocity v. And right now I will apply the Fleming right hand rule for the charges moving in a magnetic field. So this thumb shows velocity, this shows magnetic field strength, and this shows the force. So if I apply in this circumstances, so this is the velocity going to the right. Okay, it's my right. Okay, it is into the plane, and this is a force exerted upward. But this Fleming right hand rule is by default applied only for the positive charges. So for electron, I will consider the force exerted downward. So for this reason, and this is exactly the force that is given in the question F. Due to this force, this electron will move in the curved path, and because this force is acting as a centripetal force. So this is a magnetic force, and right now it is exerted towards the center, so I will consider this is exerting, it is behaving as a centripetal force, because it is always, it tries to bend the particle. So this force is equals to qvp sine theta. Since the electron entered at a 90 degrees, that's why it is maximum force applied on it. Now the point is, when alpha particle will be thrown, what will happen? So you can see that we are throwing the alpha particle into the region which have a stronger field, and the alpha particle is thrown parallel to the magnetic field with a speed 2v. So basically magnetic field will not be able to bend the alpha particle. It will not be able to accelerate it. Okay, because the reason is it is going parallel. So F is equals to qvb sine theta according to this equation. So the new force is the alpha particle have a 2 times of positive charge, 2e. Its speed is 2v. Its magnetic field where it is thrown is 2b. But the problem is the angle is 0 degrees. So there will be a no force exerted on alpha particle, and hence there will be no acceleration in alpha particle. So the right answer for this question is option A, which says that there is a no force on the alpha particle. Hi, this question is about horizontal circular motion. So, a fixed mass of mass m is tied with a string of length L. So, it is moved in a horizontal circular path. So, its speed is increased when it is increased to a certain value v. So, let's say this is its velocity v. So, at that speed, the tension which is providing the necessary centripetal force to this mass to move in the circular path, that tension becomes so high that the string breaks at the speed v. Now we are given in this question the different combinations, like you see the 4L and the 2v at this speed and this length, and the rest of the combinations we have to test that at what combination the string will break, right? So we are provided the initially the length L and the speed v where the string breaks. So let's start. So, how much force was actually at that moment? So we can find out, by the way, you can right now see that there is just one force that is providing the centripetal force. In fact, there are two forces which are exerted on it. Okay. So the one force is the mg, is the weight which is not towards the center. And the second one is the force of tension. Let's say this is the T max. Okay. Because this is a maximum tension. So if we try to write its equation, so it will be T max is equals to mv square over L. Okay, because here the radius is equals to length. So if any of the combination is equals to mv square over L, then at that combination the string will break. So for the first combination, the T prime, that is a new force. Okay, so the mass is not changed, m, and v square is 2v whole square divided by the radius is 4L. So let's see, it is 4v square divided by 4L, and obviously you can see that it has become equals to T max. It means that this is a combination of the length and the speed at which the string breaks. So string breaks. But I will quickly show you the other. So this is equals to mv square over 2L, which is, by the way, dear students, T max over 2. So it's a half of the maximum tension. So that should not be the right answer. A is the only right answer. So it will become mv square over 4 divided by 2L. So in short, this will become maximum tension divided by 8. So it is 1/8. Obviously, it is also not the right answer. So last but not least, you can see it will become mv square over 16L, which is 1/16 of T max. So finally, the option A is the only right answer. This question is about the ratio of radioactive activity of the two nuclides A and B. I will show you the solution by the two ways, two alternatives. The first is by equation, and second, I will show you the results in a graph as well. So, first of all, let us understand what is the radioactive activity. So, radioactive activity is the rate at which the nuclide, the radioactive nuclide, which is unstable, it is the rate at which that nuclide decay, how fast or how slow that radioactive nuclide decay. So every radioactive nuclide have a different rate of activity, and it is done by emitting the radioactive particles like alpha, beta, and gamma. So for example, if this is a uranium 92 238, that is a famous, when it is when it release the alpha particle, it converts into the thorium 90 234. So this is one decay, the decay of one nuclide. So just imagine if you have taken the two nuclides A and B in the two different samples, and both have a different half lives. So both will decay at their different rates. One will decay fast and the one will decay slow. So we have to take a ratio of their activities at after four half lives for the nuclide A. So let's say the initially the both have a equal activity, let's say A0. Now according to the question, the nuclide A has a half life T. It means that how many half lives will be passed. So in the time period 40, so there will be, obviously you have to divide 40 divided by T, so there are four half lives. So in that four half lives, what will be the activity after four half lives? We know that after every one half life it decays, the number of nuclides remains half, right? So it means that if I want to know what is the amount, so I will simply apply this equation, 1 over 2 raised to power n represents the number of half lives multiplied by the initial activity. So you can see that it will be 1 over 2 raised to power 4, because there are four half lives, and finally it will become A0 over 16. So this is the activity of A after four half lives. Now we will apply the same for the B. Since the nuclide B have the half life two times more means it is decaying slowly. Okay, its time period is longer. Why? Because its decay constant is smaller, right? If you remember this equation. So nuclide B, for nuclide B, there should be 2t, I mean the 4t. So it, for this, it is the total time divided by its half life. So there are just two half lives. So it means that after one half life, its amount will be a0 over 2, and then after two half lives, it should be a0 over 4, which you know already. So let me just write it again. So it is raised to power 2 times a0. This is a proper method we find out activity. So this is the activity of that nuclide B. So if we divide them, right? So activity of A, since it has a more half life, right? So it is, we have calculated it is A0 over 16 divided by A0 over 4, right? Which can be written as, because this will be cancelled out, okay? So it can be written as 4 over 16, and 4 over 16 is equals to 1 over 4. So it means that activity of B is four times less than activity of A. Sorry, more than four times than the activity of A. And the right answer is option D, which says that it is 1 over 4. Now, please don't skip the video and let us see the second method, which is a graphical method. We know that for both, the activity initially was same, that is A0 and A0, let's say at that point, when the time t was 0 initially. So for A, since you know that the half life is t, right? So it means that there will be four half lives, which we have already seen. So after the time t, it should be a0 over 2. After the time 2t, it should be further halved. Then after the time 3t, it should be further halved, and then the 4t, it should be here, right? And if I try to join all of them, so you see that this is a curve that is passing, and this amount is exactly, so right at 40, look at this amount. Is it not a0 over 16, right? And we will do the same. Now, let's quickly see what happens with this. So it is t, this is 2t. So at 2t, it will be halved, right? And then at 40 it will be further halved, so it should be this point. So if you draw them, so this is obviously a less steep curve, and this is a more steep curve because it has a less half time. So its amount is, dear students, its amount is a0 over 4. And if you divide these two, so you will get once again the same answer, option D. So I hope you understand the whole solution by two methods.